All right, we're now going to move into a new area, and what we're now going to consider is the case where we can have boundary conditions or conditions within our system changing as a function of time, and we refer to that as being transient conduction. So, looking over what we've covered thus far in all of the different lectures within this course, so we looked at 1D conduction analysis, and for that we quite often would use thermal resistances, enabling us to examine those systems. We also looked at what we referred to as being systems that are conduction-convection systems, and specifically an application of that was fins. We also looked at the case of one-dimensional conduction with internal generation. And again, for that, we were able to look at slab. When I say slab, that's a 1D system, basically a chunk of material, cylinder or sphere. And we also have looked at 2D conduction. And with analysis there, we use shape factors. And we have finally looked at 2D numerical analysis. So those are the systems that we've looked at thus far, and you'll notice that none of them deal with transient solutions, where your boundary conditions may be changing on the surface as a function of time. And if the boundary conditions are changing, what's going to happen within the solid as a function of time? And so that brings us to the area of transient conduction and transient conduction analysis. Okay, so we know that these are solutions, or this is what happens when you change the boundary conditions on an object. And so you go from one initial boundary condition to some new boundary condition, and then you're studying what happens as a function of time. And what we're going to do, we're going to take a look at a number of different methods of solution when we look at transient conduction analysis. So we'll be looking at the heat diffusion equation. Again, that's the partial differential equation. And we'll be able to look at a limited number of solutions, given that it is a partial differential equation. We have to make some rather severe simplifications for that equation. We'll be looking at another analysis technique referred to as being the lumped capacitance technique. And that basically assumes that the entire solid is at the same temperature as a function of time. Then we're going to be looking at some approximate solutions to the heat diffusion equation. And for these, we can either look at them using tables and looking up values in tables, or we can use a graphical technique that uses what are called Heisler charts. And then finally, although we won't be covering it, another way that you could do this analysis is using numerical methods or solutions. And I won't cover transient numerical solutions just because it gets a little bit more complex. And the Excel model that we developed earlier is not really appropriate for this type of solution. It would be more appropriate if you're doing this in some programming language, be it C or Fortran or something like that, where you can store very large data sets. Excel is you can do it in VBA, but we're not going to be covering VBA in this course. So those are the different techniques that we have for doing transient solution analysis. And what we're going to do in the next segment, we're going to begin by looking at a fairly simple solution that involves the heat diffusion equation, and then we'll move on and look at lump capacitance, and then finally the approximate solutions and Heisler charts. So that's where we're going in the next couple of lectures. We're dealing with transient conduction.